Good afternoon, everybody. Welcome to the 7th annual Harry Guest Memorial Lecture, and Till did confirm it's the 7th, and it's really just great that we've been able to have this special seminar each year in honor of Harry. First, I'd like to thank Till Sturmer, as always, for being the mastermind behind this seminar, and this year Robert Overman, one of the pharmacoepi students who helped organize the event. Also, of course, I'd like to thank all of you for attending, and we'll note that we do believe there's going to be a reception after the seminar outside the main entrance, the Epi department, which used to be this nice space for receptions, but now it's been devoted for students or something. So we believe there will be food somewhere in that area. And this lecture really is, as I said, is really one of those special events in sort of the life of a department. I mean, it's really not only for the pharmacoepi program that we celebrate one of our legends and former colleagues, but it's really for the department. And I think that's particularly true as I see some newer students out in the audience and thinking about many of the sort of legends of epidemiology that have been in this department, including Harry, thinking of John Castle and Al Tyroler and others. And it's really important, I think, that each year we have an event that we remind all of ourselves and really the students about the history of the department, the really important people that have shaped the department over all these decades. So Harry obviously was very influential and important to the field of pharmacoepidemiology, to Merck, and to the department. And really I think everyone would agree, he really can be considered a visionary, an architect, an engineer for our department pharmacoepidemiology program. And he really laid the groundwork many years ago to develop a really world-class pharmacoepidemiology research and training program, and really seeing and knowing of about all the outstanding students in pharmacoepidemiology. I think he would be really proud of that. His legacy now in establishing and teaching was very important to him. Students were very important. That that we've come all this way based on the foundation he laid for training in pharmacoepidemiologists. Also, one of his legacies, having worked at Merck, is that he's really helped tie together, while he was at Merck and teaching in our department, really a bridge with the pharmaceutical industry, which has really been quite important, I think, to our pharmacoepidemiology program, a mutually beneficial relationship for research and training, and Harry really laid the groundwork for that as well. And so, of course, all these threads for research, teaching, working with industry, and many other things really are the threads that we're pulling on today, that we're continuing in our sort of world-class pharmacoepi program. And so again, thank you for coming. Thank you, Malcolm, for being the speaker today as we, again, honor the legacy of Harry Guest. Thank you.
On behalf of the UNC student chapter of the International Society for Pharmacoepidemiology and the Center for Pharmacoepidemiology, we welcome you to the 7th annual Harry Guest Memorial Lecture here in Chapel Hill at the University of North Carolina. My name is Robert Overman, and I'm a second-year doctoral student in the Division of Pharmaceutical Outcomes and Policy, otherwise known as DPOP, over in the UNC Eshelman School of Pharmacy, and serve as the chair of the UNC student chapter of ISPE. Before I introduce our speaker, I'd like to say thank you to the other members of the executive committee, Mitch Conover, Erwin Miller, Laura Hester, Liz Gary, and as well as Dr. Sturmer, Burkhart, and Poole for their assistance in coordinating this year's event. In 2008, UNC students created this lecture series to honor Dr. Guest, who had built the UNC Pharmacoepidemiology program, and to remember his exceptional dedication to teaching and mentoring. Today's event gives us a moment to reflect on Dr. Guest's lasting contribution to our program, and we hope that this series will continue to flourish in the coming years. Today we are honored to have with us Dr. Malcolm Maclure, the British Columbia Academic Chair in Patient Safety and Professor in the Department of Anesthesiology, Pharmacology, and Therapeutics at the University of British Columbia. Dr. Maclure received his bachelor's in biochemistry from Oxford and his master's and doctorate of science in epidemiology from the Harvard School of Public Health. He has published more than 100 peer-reviewed articles, with his most well-known epidemiologic contribution being the development and the use of the case crossover design in epidemiology, a design he first introduced in 1991. The topics of his publication have ranged from cancer to methodologic concerns of causation and the misuse or misinterpretation of statistical methods in biomedical research, but all with an interest in improving the lives and quality of life for patients. After graduation from the Harvard School of Public Health, Dr. Maclure became a faculty member there, where he taught on epidemiologic methods. In 1991, Dr. Maclure went to work with the British Columbia Ministry of Health in Victoria, British Columbia, incidentally where he had grown up. While working for the Ministry of Health, he's developed numerous methods for pragmatic evaluation of health services and policy interventions using administrative health claims databases. These include both the way to contact patients without compromising patient health information, called camouflage contacting, as well as the use of design delays in implementation of healthcare policy to determine their effectiveness. In addition to being on faculty at the University of British Columbia, he holds adjunct appointments at both the Harvard School of Public Health and the University of Victoria. He serves on the British Columbia Patient Safety and Quality Council as well. While he continues to participation in evaluation of drugs, drug policies, and prescribing education programs, he's recently diversified into evaluation of surgical outcomes. Throughout his career, Dr. Maclure has been an innovator, and the title of his talk suggests he still has more innovations to come. We are honored that he's been willing to join us today. Please welcome me in joining Dr. Malcolm Maclure to the stage.
I understand that Harry was often surrounded by trialists who thought that epidemiology wasn't so rigorous. So that's the main connecting thread I can make with Harry's legacy. So I was speaking with my wife, doing a bit of rehearsal on this morning by Skype, and she said, rigor versus participation, I think you better drop some of those rigorous slides in favor of getting finished on time and having some opportunity for engagement. So I'm glad that I had the additional time this morning to make some final preparations. On the one hand, we have people who are keen on point-and-click quasi-science, which is really great in quality improvement, and it's particularly oriented around the Plan, Do, Study, Act cycle, which I'll touch on in a moment. And in the other corner, we have do-it-yourself rigorous epidemiologists, such as we're being trained to do, where each study is carefully designed for the particular problem, the particular drug, and for this purpose, we maybe design our own episcope, which some of you may have be familiar with from my paper on the causation of bias, where we view the skills of the epidemiologist as being able to create this camera that looks at the audience back there, such as you in the auditorium, and through a series of lenses and filters to deal with issues like random chance, confounding, misclassification, selection bias, and interpretation biases. Or repeating it in terms of causal arrow diagrams, that's what we're interested in. And these are the sources of noise, misclassification, and selection bias. And we look at the result, whether it's an XY continuous variable display or a 2x2 table. And our expertise is in understanding how all that comes together. And so the context I'm now moving into, having sold myself to the selection committee as somebody who could contribute some rigor to patient safety and quality improvement, I'm particularly interested in antibiotics and stewardship and the problem of antibiotic resistance, which connects with surgical outcomes and reducing infections. And British Columbia recently joined the U.S. National Surgical Quality Improvement Program in a big way, 24 hospitals joining in, whereas in other parts of Canada there are only about 4. So this is a big investment. And so I'll be talking about the participation rigor trade-off. I'll give you a snapshot on patient safety and quality improvement. And then I'll tell you a story of applying the case crossover method, trying to see how it works with errors, and I'll draw some lessons, and one of which is a snapshot of a course. So here was, I attended one of the Surgical Quality Action Network meetings, very vibrant, active, enthusiastic leadership, these nurses participating in quality improvement, and some of the displays of data were the kind of thing that would naturally raise questions. Very frequentist orientation. People count their adverse outcomes in the past 30 days. Here we have 2% around, this is the local hospital. This is for urinary tract infections. The NISQIP, national U.S. Overall mean outcome frequency for 30 days. And this particular hospital was counting their outcomes over the period of months when the program was introduced. And there's, they talk about common cause variation and special cause variation. And I'm thinking, what is this? And these error bars are, there's a lot, they are pop up automatically in the software. But the striking thing was how very engaged people were, and this was very understandable to everybody. On the other hand, here's the 222 hospitals at that time involved in the National Surgical Quality Improvement Program. The data analyzed in Chicago, and all the hospitals ranked on 30-day morbidity observed over expected ratios. In British Columbia, we're spending about $5 million a year for those hospitals to participate, and most of that is for nurses to do chart reviews and data entry so that we could have really rigorous case mix adjustment by the National Surgical Quality Improvement Program, so you could compare between hospitals. So we have this tension between a participatory meeting. I suppose one of the reasons that the nurses are so alive is they're glad to get away from the computer terminals and talking with each other, so there's this tension between how their time is allocated. And there's a well-known principle in safety of the efficiency thoroughness trade-off. If you're going to be efficient with regard to use of resources, you may end up cutting corners and having an unsafe context. Similarly, we have we want people to be participating. Quality leaders in the hospitals want the nurses to spend more time involved in measuring the processes and improving the processes, such as improving the timing of antibiotic and use before surgery. The problem is that they're spending a huge amount of time doing data collection for the sake of rigor. And so a hypothesis I have, a hypothesized solution is, why don't we use a case control design? After all, the outcome rate is very low. there's a huge amount of chart review going on for people who don't contribute much to the analysis, not people without outcomes. And then we could increase because they're only doing a random sample of all the charts, and then they look at outcomes. Why not take a case control approach, find out the cases, and then do a sample of the non-cases? That would free up a huge amount of nurse time, which then could be used to study processes and make improvements. So that's my hypothesis, and I think that's one situation where epidemiology can contribute a lot. However, the interesting thing is, it's one thing to talk about the participation of the nurses. It's also, you have to talk about the participation of the surgeons. And the surgeons, even with good data, are very reluctant to be told what their outcomes are. The natural reaction is, if it's high, well, our cases are worse than average. But what's important is the National Surgical Quality Improvement Program is sponsored by the American College of Surgeons. And so if it's all done according to the official NSQIP approach, even if it's inefficient, it may mean that we'll engage surgeons better. So it might end up being a trade-off between engaging surgeons versus engaging nurses. Lots of little small p politics. Oh, by the way, an interesting pharmacoepidemiology twist on this. In British Columbia, we have centralized pharmacy records for all community pharmacies, and the hospitals have those. So you can go down and say, well, let's look at the patients who have been discharged after surgery in the past, and they've passed their 30-day window. How many of them have used antibiotics? That's maybe a flag for a potential infection that was due to the surgery. Let's phone them in particular. And that we can even reduce the total, make more efficient the selection of a process for cases. So a number of things that can be done to improve the efficiency and move the nurses' time over. But now the question is there a perceived loss of rigor? That's to point out that we've got great opportunity for a case control design. Now, a snapshot of patient safety. The Institute of Medicine reports around 2000, 1999 and 2001 came out, and all of a sudden patient safety in PubMed became a rapidly appearing word. It is a very new field. What is it? Very fragmented. Everything from where you put the decimal point on your prescription all the way up to systems, the role of boards in quality improvement. So I've struggled with how to portray it, and I've come to the conclusion, what we did was come up with the top 10 competencies and realized that they could be structured from the patient, involving the patient and the family, attention to the medications, all the way up to more distal causes. So proximal causes to the patient all the way up to distal. How the layout is on the insulin pump, electronic medical records providing flags for drug-drug interactions, communication skills, medication reconciliation is the record of medication moving through the hospital with the patient, all the way up to how does your hospital embrace quality improvement. And so that's a snapshot of the complexity. It's a massive field, lots of opportunities. There is a key paradigm shift. The old way was when an error happened, the assumption was we all should be working without error. Anybody who makes an error will be identified and sent out for education, if not fired. The new approach is to say, wait a second, most errors are due to environmental contributions. Let's do a root cause analysis and find out what aspect of the system failed and what can we improve. And the interesting thing is, this was part of my selling point for getting the position, was arguing that there's a similar shift when you move from a case control study to a case crossover study. Instead of asking the question why those people get sick and those people don't, it's more like, why now? Why did the event happen now in this particular person? So a case crossover study, like crossover studies in general, are consistent with the principle of quality improvement. And you should be comparing yourself with your past and future much more than with others. And you saw that at the beginning, the simplistic analyses was a within-person, within-hospital comparison over time, and the expensive one was a between-hospital, highly controlled, risk-adjusted comparison between hospitals at the same year. So just for those who don't know the case crossover study, this is just repeating what I said. The traditional case control study is asking who did it, why them, and case crossover is why now, why not before, but also what can we do better in future. That's the key thing. Where the aim here, this is an important distinction, is we want improvement. We're not only interested in truth. We're interested in truth so that people will know what to change and make improvements. Truth is a means towards improvement, and if you're pursuing rigor so much that you're disengaging with people and not making improvements, then you're failing in your mission. So case crossover designs are good for studying multiple causes, and so it fits this very complex view of all of the converging causes from culture down to decimal points on prescriptions. However, part of this is not just to figure out the cause, but also to move to quality improvement through the plan, do, study, act cycle. So the planning, what we're going to do in our next improvement, here's what we then do it. We carry out the plan, we study the impacts, and then if we weren't successful, we make further changes. Sometimes they have to go through multiple cycles before they finally achieve improvements. This thing had an industrial origin, and important to know that it was designed by these guys and intended to reflect a scientific approach. So there's an analogy with developing a hypothesis, converting that into an operational experimental plan, implementing the plan, and then doing your analysis, and then maybe modifying your hypothesis, maybe modifying your plan, and so forth. So that was deliberate. The thing to remember is that it was for relatively uneducated workers, and the statistical analyses of those charts involved rules of thumb that a relatively uneducated person could use, counting the number of points below a certain line. And why? In order to engage them in the quality improvement process. So right from the beginning, this was deliberately designed to be for engagement and potentially at the sacrifice of rigor. So here I am in 1987 visiting Karl Popper for some career advice. The upshot was that yes, policies can be testable, but values are contradictory. I guess that was a contributing cause to my moving to Victoria and getting into health services, epidemiology, and evaluation of policy. Popper said there are three ingredients of testability, testability being the criteria that distinguishes science, rigorous science, from pseudoscience or sloppy science, and that is the precision, deviance, and universality of the statements, of the hypotheses, and whereas pseudoscientists cloak themselves in vague, often conventional, some they may be very unconventional, but vague and with caveats, so that evidence has a difficulty refuting those views. So I figured, okay, well that could apply to the plan, do, study, act cycle. We could make plans more precise. We could, the doing could be more universal in more settings, the analysis more precise, and the act, the change, could be bigger, and that would all make that cycle more rigorous, according to Popper. So I have made this case to the search committee that I'm a good choice, because case crossover studies is a rigorous way of looking at triggers of heart attacks, triggers of adverse drug effects, and so forth. I still think that there's a potential for it to be used in incident reporting systems, which were created for capturing incidents in hospitals. So when an incident happens, you're supposed to enter it, and if it's serious, there was legal reasons for doing that. Now we want to be entering near misses, because they're very informative. How come you had a near miss and it didn't go to an error? How come it got that far? People are often more forthcoming with information about near misses because it didn't harm anybody. So those incident systems are created, but there's a typical selection bias that the more likely, if you have a causal hypothesis in mind, you may be more likely to report the incidents. There's a lot of underreporting. And the more routine errors, people say, well, I didn't report that because we always have that problem. So but there's still a potential when you're reporting having an incident. Can we, with one or two questions added to that system, get a bit of control information? And one of the most important things is fatigue. And in fact, when I was urged to apply for the position, I first thought, I think they're going to want a clinician, not me. But I thought, gee, I wonder if somebody's used a case crossover method for looking at medical error. And sure enough, there are a couple oriented towards fatigue, and very strong relative risks, 4 times the higher risk of insulin pump errors in ICU if the nurse has been on multiple shifts versus if they're fresh. So I wanted to make some progress, apply this method to some errors, and hadn't really got around to it when I got an invitation to the Rotterdam Erasmus summer school 2 years ago, which happened to coincide with our plans for a 6-week vacation. So I guess maybe the first error was that I hadn't done anything on it until the vacation. So I kind of hope, well, maybe we'll have some errors on the way that I can sort of use it for demonstrated. And by the second day, we had left behind a suitcase, lost an iPhone, and my son had got on the wrong train. And about day 4, we had lost a jacket and a dress, and I had a near miss, which was seeing the standard shift car rolling slowly down the driveway driverless. And I managed to rescue that car by running after it. And all of those errors actually were made up for by a relative bringing us the suitcase, and another one finding the cell phone in the back of the car, and another near miss was when my son's girlfriend arrived, and without exactly the right papers to get across the border, but she managed to persuade them She was and I just want you to look at my son. He's figures. Both of these people figure in the next slide. So here we are, and we are half an hour before getting onto the cruise ship. And this is a kind of bit of a pharmacology story. We're all using up the beer that we're not allowed to take on board. And a few minutes later, his girlfriend joined the team of observers and said, "Liam, where's your rucksack?" He's not wearing a rucksack, we all are. So Liam and I jumped into a cab, raced back to the hotel, found it sitting in the lobby, and made it back to the ship on time. And that was another rescue by a team member. And these were a new party. They're family member of the girlfriend, the family of the girlfriend. And it became a joke, all of these errors. We were having a great time. And here we are the next day in Berlin, and you can see he's wearing his rucksack, and everybody's happy. And this has been important because we decided to save money and not take the cruise-oriented train ride in, but take a much cheaper one. And so, when we had the choice of taking a later train back or an earlier one, we all agreed, let's be safe and take the one that's got an extra 2 hours. We don't need that additional time. So here we are having a great time in the midst of making another error. We got back to the train station. We'd checked the timetable. There it is. But when it didn't arrive, and we then noticed the asterisk in German footnote saying, not in July and August. And so for the next 3 hours, we were all biting our nails on 3 different trains that made it to the cruise ship with 10 minutes to spare. So what was also important was by now discovering the huge importance of participation, and the potential for conflict around error could have been huge, could have been vacation ruining, but because of this unexpected side effect of making a kind of an amusing approach to applying science to vacation errors, we had this real experience that they talk about, that team resilience, participation, teamwork is one of the most important things in patient safety. So the errors went on and on. There was a whole sub-study of texting on these European inexpensive text phones, and unfortunately the experiment was terminated early when one of the cell phones got lost. One of the challenges was grouping all these different kinds of errors to be into similar kinds of outcomes, and also you begin noticing things, errors that you make all the time that you discount. We began to say, my son would say, "Dad, there's another one," and instead of it being this irritation, well, it was always a little bit of irritation, but it was also this plus. We've got another learning opportunity, another example, and it became a joke because we quickly detected a pattern. The highest risk was in transitions, when you're getting up and leaving something and going from one place to another. And indeed, what are the biggest risk time windows in patient safety is transitions, where a new team takes over, when a patient is being moved from one place to another. That's when a lot of errors occur. So grouping things into new places, new people, different language, and different technologies. Of course, on a vacation, those are the things you want. These are the other things that are much more manipulable. So some things are more manipulable than others. there were quite a few other rigorous slides that my wife persuaded me to remove here, and jump right to one of the conclusions was that it was, with the case crossover, you want to define your window of risk and hazard period. In fact, just before this, we were in a class discussing and getting confused on a racehorse injury study on what windows refer to what and so forth. But being clear on that is quite important. And I realized it all became very confusing when an error happens here, but then sometimes there's this huge opportunity for it to be corrected. So the first time the e-reader was lost, it was in Copenhagen, to which we were coming back to, and the police had a very excellent system, and we got an email telling us where to go to find it. The second time it was lost, it was right near the end of our trip in Holland and on the train, and so we never got it back. And so how does the follow-up window affect? It seems to me you've got to have a sort of ambispective design in it, and the nature of these windows are kind of hard to define. I mean, one of the windows, the very last thing that was returned was about a year later, my son's jeans, when our host returned them to Montreal. But over and over again, it was team members, relatives, friends, who came to our rescue. I found it quite difficult to apply the method rigorously, but it was yielding all of these benefits, insights. One of the insights was about the counterfactual, thinking about counterfactuals, how you can actually sort of figure out the counterfactual from one incident. So here's it's much more apparent when it's a visual example. So here we are in the hotel in Copenhagen, taking suitcases out to the car. That's how it got left behind. It was, and you can just do a mental replay. If it had been parked where everything was visible and nothing hidden from each other, it wouldn't have got lost. Likewise, the DVD left behind in the south of France was under a pile of other stuff, whereas the other one was taken because it wasn't covered up. There's this whole field within patient safety of engineering, which is relevant to the conversation I was having yesterday with Daniel Westreich about epidemiology of public health being a kind of engineering oriented, thinking about solutions that we could implement. Similarly, one of the tensions in the quality improvement field between the enthusiasts who are doing the plan, do, study, act cycle and the randomized trial guys who sit back and say, well, we've tested it and it doesn't work. And I've watched the debate and I've wondered and it occurred to me they're dealing with different counterfactuals. The RCT people say, well, you made an intervention versus standard care. That's the counterfactual, and it didn't make a difference. And the quality improvement people are saying, yeah, but we already have a different counterfactual in mind, the future one. It can be changed. There's a further improvement that can be made. And so there's this interesting tension. This is the gas pumps I'm used to in North America. No ambiguity there. This was driving a diesel. I thought, oh, well, there we go. I know what to use. It's the one that says, and I glanced at this, I think that's a brand. I don't know what blue is doing on there. But I picked up this and was loading it into the car when I noticed this. Part of the difference in perspective is imagining a future counterfactual, a better design. And it's not clear that epidemiologists have a role in that. So here are my conclusions for epidemiologists. I was striving for rigor, but I got mixed results. I found it was fun, useful, participatory, but I didn't really achieve rigor. Now, part of it was, I also didn't produce the obvious solution, which was a checklist. Like when you're on vacation, I mean, it's much more like the clinician in the real setting not having time for the rigor. But some interesting things still came out of it. What was interesting was that if you just ask about one incident or one class of incident, then there's all of this stuff of, yes, transitions and new places and different language and so forth. But if you say, and those are overwhelming, and sometimes the uniqueness of the event is so strong, the uniqueness of the circumstances, you say, I can't see how to group this. I don't see how I'm going to group this. That was my initial reaction when our first couple of days of errors. I thought, oh yeah, but that's so special. That's not going to add up. But if you then say, well, I'm going to match it. Think of a similar situation we are in. We've also been doing transitions elsewhere. What's the difference? How come we can leave hotels without leaving things behind, but when we're with friends, we leave things behind? Well, it's because of the clutter. There's less clutter in the hotel. How come we did better when we were a small family by ourselves rather than with 3 families? Well, there was more clutter of people, extra cars, harder to... So some of the signal of the secondary causes become more evident when you match informally. This is all done in the head, in conversation, a little bit of matching with a similar event where you didn't have the event. So there's the element of the case crossover design being useful when it's not being done very rigorously, and definitely not with a big sample size. As soon as you figure out that you're doing something stupid, you're not going to say, let's keep doing it until we get a big enough sample size. So you keep changing, and so you're always working with very inadequate statistical power but making improvements. So I found it was in some ways too reductionist. The complexity was, I had a slide showing the complexity, which was too complex, but the thing about coincidence of rare events, there's this official model called the Swiss cheese model of errors, where we're always making errors, but we have these barriers that protect us from the errors going on to harm. And what happens is when you look at these error investigations, incident investigations, you find out that there was an unfortunate coincidental alignment of the holes in the Swiss cheese, and an alignment of errors that are each one of them a little bit improbable. They happen to occur together. So that's especially problematic. I mean, most of our, we have interaction terms in our models, but we don't make a big deal about it, and I don't ever remember using a model with a three-way interaction, let alone a four-way interaction. And here we're saying a lot of the key incidents are alignment of 3 or 4 coincidental cofactors or events. So a lot of challenge there in applying it. As I said, it was unclear how to apply the effect windows, especially with this opportunity of varying durations to recover the error. The ambispective design is challenging. So in general, there's as I mentioned, a tendency to dismiss errors that are unusual, and that kind of gave me an insight into why there is a cultural shift, why clinicians have difficulty in embracing some of this, is that for them every patient is different. They see the uniquenesses and have this resistance to generalizing, so I have some sympathy for that. Conclusions for NSQEP nurses. I have to grant proposal that I'm hoping will be funded to actually test this case control design and see how much we can free up nurse time. There'll be a lot of politics in it, finding out whether surgeons are skeptical about the design, what's NISQIP's attitude, are they going to, can we do it in parallel, and so forth. And then, with the freed up time, hopefully they can move over towards doing that process evaluation stuff, like finding out about what, apparently the timing of antibiotics is really difficult because you don't know what the timing of the surgery is going to be often, unless you set up a system for finding out what are the delays down the road. And so each little hospital has their own quirks, and so it's very localized kind of research where you want to use a method that's good enough to get you to focus on causes that are probably influential, make a change, and see whether it has an impact. It's a lot easier at the beginning when you're dealing with the stronger causes. It's going to be interesting to see, after we've been in the quality improvement movement for a while and we've dealt with the big causes and we're getting down to the smaller ones, I think the need for concern about design, especially the need for control groups, because all of this is kind of, it's not rigorously controlled. They're hoping, they basically are getting differences. Some of them, like one of those slides, they got down to a 0 rate for 4 months in a row, and that's achieved statistical significance. So essentially an informal comparison, what was unusual during the error situation, how come when we have near misses, what is it we do better then, and what can we do in future, particularly to change the structure of things so that we don't have to rely on our cells being constantly vigilant when we know the system forces us to get tired, to do ever more patients per hour, and so forth. Conclusions for instructors, I have a short course which I shall be doing each year. I did it for the first time in January at Harvard School of Public Health on familiar ground. 4 parts. First is this, looking at individual incidents, thinking causally about individual incidents, and then looking at a whole bunch of incidents over time. So you do a run chart and see whether you can improve, and then also, looking at propensity for the causal factors to happen, and then integrating them all with, on the 4th day, with attention to design. And so this is the final conceptual thing that emerged from the first time of getting through the course. The students were kind of saying, where are we going? And I came up with this. Essentially, when you've got these data in the healthcare system, for some people, for the majority of people, it's just, oh, well, it's more monitoring data to increase our accountability, and when there's an error, we need to have an incident report. If we're lucky, we'll have time to talk about it. Actually, that might need to, it's sort of halfway between point and click science. It's more really under quality improvement. A run chart, you post it on the wall and say, okay, I glance at that. I'm not really involved with the quality improvement committee. I go along with it. I glance, but I'm a little bit more concerned about my outcomes than I used to be. I sometimes stop at the run chart and look at the little flags they put on them that are, here's what we did and here's what's, but as far as I'm concerned, I don't want to talk about study design. It's basically before and after, are we doing better? So that's kind of, and often that'll be fine. The point is, for many people, I have nothing really to contribute to that. There's an analog at the other end of the spectrum. A lot of attention to directed acyclical graphs, really rigorous thinking about causation, and applying a Bayesian approach. Like, why should each hospital be considered a separate independent experiment? Like, we're all doing the same thing. If it looks like you're trending down, why can't you use some of the evidence from other hospitals that when they're also trending down to say, look, yeah, we don't have to wait for local statistical significance, and there's a lot of other sophistication that can be done. And instead of these run charts, let's talk about multivariate time series analyses, and especially if we can have a control group. So one could, and one needs to, for very important policy decisions that are generalizable, to do a really, really good analysis. But when it's more or less established, and now the goal is different. The goal is to engage people in local improvement using methods that are quasi-scientific, that aren't too complicated. So this kind of new specialty that I need to have, I've been actually developing over 20 years of being in government, where I make compromise after compromise, trying to have control groups, saying, yeah, okay, we could do it for shorter, and yes, we don't have to randomize everybody, and yeah, we could, and so it's become part of my unplanned expertise, is to kind of make judgments about when is it okay to compromise, and when do I say, no, you can't do that. That's really going to screw things up. For the students to be aware of a spectrum at each one of these levels as you progress from hypotheses to final, or it's never final, evidence, and going around the quality improvement cycle, you make judgments about is it worth it to, and generally speaking, if there's a lot of participation, it's not going to be worth imposing too much rigor so that people are disengaged. And that is just some of the things I've been doing in the ministry. One of the conclusions I have had is that if you can persuade people to have a control group, even when they don't know exactly what the measure is going to be, and what they haven't even agreed, but they do agree that they're going to have a control group, then people start becoming researchers. They say, well, what's going to be different between the two? I say, exactly. And they say, well, what could we measure? Good. And so they come up with these education. That one was antibiotic prescribing for acute bacterial sinusitis, and because it's almost like if you didn't know that there was a randomized group to early and delayed, and that the early blipped up here and then the delayed blipped up here, you would be pretty concerned. Well, gee, is it having an effect? But because of that control group, not only does it improve the believability of the analysis, but it causes people to start thinking about what's the difference, what's the measure. Oh, then our intervention should really be focused towards that. So the provinces that had more investment in a control group to evaluate the education on better prescribing had bigger impacts. I don't want to make too much of that correlation. So that's basically the message, that there are a lot of patient safety officers worldwide that they're going to come from all kinds of different disciplines, being saying, oh, you'll be our patient safety officer or a quality improvement person. Go out and do a short course, and you might, oh, did a course in epidemiology, that's great. So there's actually quite a large cohort of people who need to be trained in a different way than we usually do. And this trade-off between participation and rigor is something that they need to themselves understand. Now I invite your participation.